So, good afternoon. Me and my team are going to explain our topic, understanding intelligent agents. Intelligent agent is a core concept of artificial intelligence. I'll be explaining how they work, how the performance is being measured, and how what is the task environment, and the different agents being used in real-time scenarios. What is the performance measure? So, to determine the performance of an intelligent agent, we need a way to measure its effectiveness. This is where the performance measure comes in. The performance measure tells us how well the agent is performing its tasks, and it gives guidance on the agent's behavior when it's learning or adapting to the scenario. And most importantly, it defines what success means to the given scenario. Key factors in performance measures. The key factors involved in performance measures, which are efficiency. Efficiency is when tells us how well the agent is using its resources. Speed. It tells us how in how much time the agent is able to complete its task. Accuracy. Accuracy determines the correctness of the agent when it's deciding its actions. It can tell how correct and how accurate the decisions are. Adaptability. Adaptability is a feature of the agent which enables it to change according to any changes occurring in the environment. So let's take an example. As for a self-driving car, the performance measures involved in a self-driving car are whether it's avoiding accidents and whether it's avoiding accidents and how well it's using its fuel, the comfort of the ride, and whether it's following the traffic rules, and whether it's able to reach the correct destination. So rationality versus performance. It's important to distinguish between rationality and performance. So a rational agent chooses the best possible action with its given knowledge, whereas a performance judges based on its outcomes. So an agent can be rational but can also make poor decisions because due to the quality of the data or any unpredictable changes occurring. So flexibility in agents. Flexibility is also another important characteristic in intelligent agents. Intelligent agents need to learn to react and respond to changes happening in the environment. They should learn from their experiences so that they can make more proactive based decisions in the future. So what is a task environment? A task in so when it, the environment in which the agent operates is called the task environment. It's usually associated. It can be described. It's associated with the it can be said it can be associated with the physical or the virtual settings. It can be associated with the other agents, or it can also be the sensors and the actuators as well. This task environment is described by the peace framework. So, peace framework overview. What is peace framework? So, to describe the environment task system systematically, the peace framework is we are using the help of peace framework. Peace stands for performance, environment, actuators, and sensors. So, for an example of peace framework, let's take an autonomous taxi. So, the performance can be set as the safety, speed, and the comfort of the ride. The environment are the roads, traffic, and the weather. The actuators in it are the steering, brakes, and the display, and the sensors are the cameras, GPS, and the radar. So, just to give us a summary of all the points, performance measures evaluates the agent's success. There are different agent types which vary by flexibility and rationality. Task environments are used to determine or define the agent's context of its for its task, and then the piece framework is used to structure the agent and design structure and design intelligent agents effectively. Thank you.
So, hi everyone, this is Brunda. So, now I'll be speaking about properties of task environment. So, what is the task environment? In artificial intelligence, a task environment defines the world in which agent operates Understanding the properties of task environments help us design better agents suited to specific tasks. And okay, let's explore the key properties one by one. So the first one is fully versus partially observable environments. So a fully observable environment allows the agent to access all the necessary information about the current state. For example, a chessboard is fully visible, so the agent knows exactly what's happening. In contrast, partially observable environment provides only limited information. Self-driving cars, for instance, cannot detect obstacles due to weather, traffic, or sensor limitations. So the next slide is about deterministic versus stochastic environments. A deterministic environment means that an action always leads to the same result. There is no uncertainty like in a calculator. On the other hand, in a stochastic environment, actions may produce different results due to randomness. For example, a robot walking on a slippery floor might fall even if it follows the same steps each time. So in the present slide, we are going to talk about episodic versus sequential environments. So in these environments, the agent actions don't depend on previous ones. Each task or episode is independent, like identifying objects in images, but in a sequential environment, past actions affect future ones. Playing chess is sequential because each move changes the future possibilities. Static versus dynamic environments. The static environments remains unchanged when the agent is thinking or deciding. Crossword puzzles are a good example. In contrast, a dynamic environment changes over time. Even while the agent is choosing an action, for example, in traffic navigation, roads may get blocked or vehicles can move unpredictably. So, discrete versus continuous environments. A discrete environment has a limited number of clearly defined stages or actions, like a digital clock. But a continuous environment includes infinite possibilities like steering a car, where actions like turning the wheel or braking vary smoothly. Single versus multi-agent. In a single agent environment, only one agent is operating. Multi, such as solving a game, but in a multi-agent environment, several agents interact and sometimes complete or cooperate. A soccer game with multiple robots is an example of a multi-agent setting. Known versus unknown environments. In a known environment, the agent understands the rules and outcomes of actions. It can plan effectively, but in an unknown environment, the agent has to learn or explore to understand what actions will lead to which outcomes. This adds complexity to its decision making. So this is all about about different task environments.
So today we'll be speaking about types of agent in AI. First one is simple reflex agent. The simple agent acts only on the current process without considering the past using conditions, action rules, if can rules. Example: a thermostatic that turns on the heat if the temperature is below a certain level. Limitations cannot deal with environment where the right action depends on the history. Model based reflex agent maintains an internal model of the world to keep track of aspects not visible in the current process. Can handle partially observable environment. Use both current process and stores model to decide actions. Example: a robo vacuum cleaner that removes the layout in the room. Goal based agent acts based on the goal it wants to achieve. Evaluates future actions by checking which on helps reach the goal. More flexible than reflection, but requires more computation. Example, a self-driving car chooses the best route to the destiny. Utility-based agent chooses the action based on a utility function it measures the measures of happiness or a success. Helps in decision making when a simple goal or op- option exists. Aims to maximum total utility over time. Example, an AI that recommends products based on what brings the most satisfaction of the users. Learning agent can help from the past experience to improve performance. Has four components: learning elements, performance elements, critical and problem generate. Become better over time without human interactions. Example, a chatbot that improves responses over the time based on the interactions.